When we're looking at graphing for this class, I want to preface it by telling you would definitely want to do these things in Excel. Excel can do all of these graphs, make them inch perfect with a couple clicks. We're going to learn how to do that as we work through our data display project later in the class. But basically, the information that I'm going to give you here is going to act like you have to get out a ruler, you have to get out paper and tell you how you would make the graphs if that was the case. But absolutely in real life, you would want to use a computer program in order to do these concepts. So the three graphs that we're going to be looking at for qualitative data are pie charts, bar graphs, and Pareto diagrams. Pie charts, when we create them, basically we need to have qualitative data, which means we can just put people into the box that they belong, or experimental units into the box that they belong, and say this person belongs to this category, this person belongs to that category, but don't have a naturally occurring numerical scale. So the first thing that we're going to do is determine what categories we want to display. Once we have our data broken down into categories, then we're going to see how many data points fit into each category and take the number of data points divided by the total in order to get the relative frequency. So basically, that frequency is going to be a percentage that we can display on our pie chart. The formula is going to be part represented by the group divided by total number of experimental units that we had. That's going to give us a decimal. If you multiply it by 100, it'll get us to the percentage. If we take that same decimal and we multiply it by 360 degrees, which is the whole way around a circle, or the whole pie that we're going to be creating, then it's going to tell us the central angle that we need to use in order to create that piece of the pie. When I talk about a central angle, basically a central angle is in the center of the circle, how many degrees do we need? So this formula, basically taking part over whole times 360 degrees, will let you solve for the central angle. You then get out a protractor. Again, we won't actually use protractors in this class, but the idea is you could get out a protractor and actually physically draw this pie chart so that it was to the exact right specifications. In the end, you'd want to include a key which would identify which color goes with which category so that it's easier for the audience to read the graph. So let's say I asked 50 people what their favorite sport was, and this is the data we got. 3 people said baseball, 15 basketball, 20 football, 2 other, and 10 soccer. First thing we want to do is find the percentages and use them to find the central angles. So we know there's 50 total people. For baseball, I do 3 divided by 50. My calculator would tell me 0.06. If I took that 0.06 and multiplied it by 100, I'd find that 6% of the people we asked said that baseball was their favorite sport. If I took that 0.06 and multiplied it by 360, that would tell me how many degrees the central angle would be. In the next slide, you're going to see all the answers to this. So here, when we're doing the percentages, part over whole gives us these decimals. When we multiply by 100, it gets us to these percents. Same idea if we take those decimals we got above, but instead multiply by 360 the degrees of the circle. This tells me the central angle for each of these pie pieces. So again, this is what's really going on when the computer generates a pie chart for you. In this class, you will never have to draw a pie chart by hand that you're graded on. There will be a pie chart included in your data display project, but again, it's going to be 2 clicks that you do in Excel once you have the data entered properly. In Excel, a graph is going to look like this. Perfect circle. Again, it's using computer math in order to generate these exact correct central angles in here. What I want you to take from this is that I can see what category based on the key goes with which portion of the graph. When you guys have homework questions on this, you'll be given the table of data and potential pie charts to match to it. Really, to answer those questions, you'll just do some quick division and see what the pie chart percentage should be. Or you can really eyeball it and say which one properly has the largest piece of the pie, being the largest section from the table. But basically, you're just going to need to say, if I had this data, which of these pie charts would be the correct representation of it. When we create a bar graph, same idea. Find your categories, find your counts in each category, except I'm not going to have to convert them to central angles or percents. Instead, I'm just going to have to choose a proper vertical axis and make bars that go up to the proper number on that vertical axis. Two things that I definitely care about. I care about that the labels are along the sides, so make sure that you have the axis labeled on the bottom. Each bar can be individually labeled for what the category is, but the y-axis should be frequency or people or something that tells you this is the number of people who gave this specific answer. Another thing I care about is that the bars are separate, do not touch, and the first bar does not touch the axis. The reason I care about that is because histograms have bars that do touch, and the first bar does touch the axis. Those occur with a quantitative variable. Here, when we have a qualitative variable, we want to make sure those bars stay separate. So, we're going to use the same data and see what it looks like as a bar graph. Here you can see that we have bars that go up to each of the counts. I really should have the word frequency written here the way it is, kind of across this axis, but the bars are labeled, the bars are separate. If you were drawing this by hand, I would want you to make sure the bars make relative sense, so I wouldn't want this 15 to be lower than this 10, but I wouldn't need you to go with a ruler and make everything exactly right, because again, the computer's a better way to do that. Last type of graph that we're going to talk about here is a Pareto diagram. Basically, I include this because I find Pareto diagrams interesting. It's just a slight change to the bar graph. All you're doing is taking the bars as they originally were and now listing them either largest to smallest or smallest to largest. Doesn't seem like a big change when we only have 5 bars. Here's what our new Pareto diagram is going to look like. Really, we could make those comparisons with only 5 bars if we didn't put it in this order. The example I like to give where it would matter is, let's say that I wanted to look at the defense budget of all the countries in the world. If I just decided to do them alphabetically, you'd see a bunch of tiny bars you couldn't really compare. Then you'd see America with a huge budget, Russia, China, and they'd be spaced out where I couldn't really tell how close they were to each other. As opposed to doing it as a Pareto diagram, where in that case I'd see, here's the largest military budget, here's how much smaller the next one is compared to the largest. I could make comparisons between countries that were very close. I could see that if I go down the row, I can compare something like, what is the military budget of Belgium compared to Egypt? And since it's in a Pareto format, I could say, well, Belgium is 12 countries greater than Egypt. If instead I just had hundreds of countries laid out alphabetically, those kind of comparisons wouldn't be as meaningful or easy for the audience. So even though for the sake of our class, Pareto diagram is somewhat extraneous, I don't think you're going to get many questions on it, I do think it's an important concept, and I do think it's something that you should be aware of, that this is a special type of bar graph where you put the bars in order. If I needed to answer questions from a pie chart, let's say I'm given this pie chart and asked which restaurant was the most popular. To find the most popular, I'd want to find the largest bar. It's this one in the top corner. These probably aren't great choices for the color scheme, so it's a little hard to tell what's what, but that really is supposed to be McDonald's at 26%. When it asked me which restaurant's the least popular, that would be this 5% gray, which I believe is supposed to represent Arby's. What percentage of respondents chose Chick-fil-A? So I see Chick-fil-A is this darker blue, so it has a label of 18% that chose it. What central angle is used to create Taco Bell? That's a little tricky. Taco Bell is this light green. I believe it's up here at 21%. So I need to know if it was 21% when I multiply by 100. When I divide by 100, it becomes 0.21. If I then take that 0.21 and multiply it by 360, that's how it'll arrive at the answer for central angle. So you can see down here, we've done 0.21 times 360 and found that that central angle should be 75.6 degrees.